Okay, I'm going to go through this fast again to make sure the video doesn't get too long. But feel free to just stop it, rewind it, whatever you need to do to have it be beneficial for you. So right here I'm looking at 4 different 45, 45, 90 triangles. And they're kind of 2 different situations. If I look at where I know the value in both of these cases, it's a leg. So in these 2 I'm given a leg, but in these 2 I'm given the hypotenuse. So your first thing you have to make, a decision you have to make is it 45, 45, 90 or 30, 60, 90? These are all 45, 45, 90. Then you have to say, am I given the leg or am I given the hypotenuse? And you're kind of working your way down the system. Well, whenever you're given the leg, to get over here, you multiply. So given the leg, to get this side, you multiply. And then in these cases, if you're trying to get to the leg, I guess in this case we're going this way, but they're both the same thing, you divide. So down here we're going to divide. Notice in every single case it's by radical 2. That's because they're 45, 45, 90. So you want to have in your mind this thought that whenever it's 45, 45, 90, you're using radical 2 only. Not a regular 2, a radical 2. The square root there has a meaning, so don't start dividing stuff by 2 or multiplying stuff by 2. It's radical 2. So in terms of what this looks like, if I multiply 7 times radical 2, that's super easy. It's just 7 radical 2. You don't actually do anything. If I take 8 radical 2 and I divide it by radical 2, it just becomes 8. Again, those are the 2 kind of easy cases. Then down here, it's a little bit more complicated. If I take 10 radical 2 and I multiply it by radical 2, these 2 things together become a regular 2. So this would be 20. So anytime you multiply the same radical by the same radical, it just takes the radical off. Over here, I've got 26 divided by radical 2. This is the most tricky case. So this is the one where I can't have a radical on the bottom. So in order to get rid of it, I have to multiply by radical 2 on the top and the bottom. That gives me 22 radical 2, or 26 radical 2 over a regular 2. Again, same thing here. Multiply the same radical by the same radical, and it makes the radical go away. Well, 26 divided by 2 is 13. Now, just a real quick note, up on the board, it says that when I go from here to here, it's 1/2 times 26 times radical 2. That's the note that's on the board. That's actually quite a bit faster, easier way to do that. So, don't forget that right up at the front of the classroom, there's a real nice shortcut on how to handle the specific situation when you know the hypotenuse and you're trying to figure out the side. These are now 30, 60, 90. And again, I just have to kind of keep track of what I know. So here I know the short side. Here I know the long side. Here I know the long side. Here I know the hypotenuse. So it's just, in each case, I gotta keep track of what am I given. Well, this is one of the easiest cases. If I know the short and I'm trying to get the hypotenuse, this is just times 2. 7 times 2 is 14, and that's the answer. In this case, you cannot go from here to here. There is no option for this. You always want to go to the short leg first in 30, 60, 90 triangles. So to get here, to go from long to short, I have to divide. That's written on the board, it's in your notes, however you need to remember that. But to go from long to short, I have to divide. If I divide this by radical 3, it just becomes an 8. Now this problem becomes the same as this problem over here. Going from short to hypotenuse is times 2. And of course, 8 times 2 is 16. Over here, kind of same concept. Going from here to here, it doesn't work. There's no way to just go straight. I mean, there is, but it would be a lot of formula to memorize. The easier way is just to come around here. Always go to the short leg first. So when I'm going from the hypotenuse to the short leg, I divide by 2. I'm trying to make it smaller. And so if I divide 10 radical 3 by 2, it's just half of it. Instead of 10 radical 3, it's 5 radical 3. And then to finish this off, to go this way, I multiply by radical 3 to go from, to figure out how to go from the short leg to the long leg, it's times radical 3. And so if we play that out, that's going to be 5 radical 3 times radical 3. Well, this is just a regular 3. So that would be 15. Over here in this next one, I've got the long leg. To go long to short, it's just the same as we did up here. Long to short is divide by radical 3. So I've got 18 divided by radical 3, which I have to rationalize because I can't have a radical in the bottom. That gives me 18 radical 3 divided by a regular 3. This together is just 6. So my short leg is 6 radical 3. Then I got to take this and go to here. Well, the way I go from short leg to hypotenuse is always times 2. So if I take 6 radical 3 and double it, instead of 6 radical 3, it's 12 radical 3. We just double it, just twice as much. Over here, these are the ones where we've got to know whether we have a inside or outside. So I've got outside here, outside the triangle, and this is the only one that's inside. So when it's outside, I use that times the whole thing, right? This whole distance. Outside is this times the whole thing. The inside one is the one where I just use the 2 parts. So on all 3 of these cases, I put whatever is outside first, square root, and then I just use these 2 numbers. So 4 times 16. Over here, my square root is going to be these 2 numbers. 12 times 16. Over here, it's going to be these 2 numbers. 4 times 12. So this is radical 64, which is 8. This is radical, I believe this is 192, which doesn't simplify, so that's just done. And this is going to be radical 48, which doesn't simplify, so it's done. These are the ones that are a little bit more complicated. If you want, there's a little trick you can use for these. You could just call this distance right here, we'll put in a new variable. We'll say that it's A, okay? And so now if I take, this is an inside number, so 48 is the square root. Inside numbers go to both pieces. So it would be 64 times A. And so then if I were to solve this, I would square both sides. The purpose of that is to get rid of this. And so when I do that, I've got over here 48 squared is equal to just a regular 64A, no more radical on top of there. And then I would divide both sides by 64. And so now, if I just put in my calculator, if I put 48 squared divided by 64, that would give me A, and it comes out to be 36. Well, that's not what the question's asking for, right? We put that A in there, but the question is asking for this whole distance. And if I know this piece is 36, I can just add this and this together to get the whole. And so I would know x is 100. That's just, it's kind of a shorter way to do that to make your algebra easier. So same idea over here. If I don't like this, if I don't want to use, like I could use x minus 36, right, in this space. But if you don't like that, if that feels like too much algebra, then just make a new variable, call it a. And that way I can say this is inside between these two. So 6 radical 85 is the square root of 36a. This times this. Same idea. I can square both sides. And now I've got 6 radical 85 squared is equal to 36a. And then I'm just going to put this all into my calculator. All right, so to figure out what a is, I would divide both sides by 36. So remember to use the parentheses. So you're going to put that in your calculator exactly like that. And then divide by 36 to get a. And then whatever you get for a, you're going to get this answer. I'm going to let you guys do this one on your own. You're going to get this answer. And then just know that your x is going to be 36 plus whatever you get for a. Right? So you'll have to add those together to get that final number. But I'll let you finish that one up. Over here, notice on all of these, I'm given two sides. See? Two sides, two sides, two sides. What that tells me is that all of these are Pythagorean Theorem problems. All the 30, 60, 90s, they only gave us one side. And so on all of these, I've got two, and I'm trying to figure out the other. So I'm just going to quickly label these A, B, and C just for myself. Just an easy way to keep track. And it really doesn't matter which one's A and B. All that matters is which one is C, that I have the right one in the C spot. So if I follow this every time, I can just go through all these and I can say, all right, I've got B squared plus 7 squared is equal to 12 squared. Here I've got 9 squared plus 12 squared is equal to C squared. Down here I've got A squared plus 10 squared is equal to 14 squared. Over here, 18 squared plus B squared is equal to 20 squared. And then it's just a matter of solving this. So if I wanted to figure out what B was here, it's going to be the square root of 144 minus 49. Because this is 144 and this is 49. So I'm just squaring those kind of in my head, actually. This one, to figure out C, it's going to be the square root of 81 plus 144 is equal to C. So the square root's on there to get rid of the square. I'm trying to undo this part right here. And so that is what's making this in the problem. So let's set these up. So for this one, man, I can't remember what 14 squared is, maybe 196. But anyway, A is going to be the square root of, I feel like it's 196 minus 100. And then over here, B is going to be the square root of 400. So this is the 20 squared minus 18 squared, I really don't know. And all of those are just going to go in your calculator. And like if they don't come out even, so let's do this one just for example. If I put this together, this is just 96, right? Well, there is no even square root of 96, and so your answer just stays. You just leave it that way. And that's going to be the same kind of for all these. Like this one's going to be 95. And you just leave it. So all you really have to put in your calculator is just what is this, right? So in your calculator, you're just going to put 144 minus 49. And that will come out to be 95, and then you just leave that underneath the radical. The only time you do anything different is if it actually came out to be a perfect square. Then you'd want to finish it off. But I don't think any of these do. And that's it.